Hello, in this video we are going to learn about the inverse of 3 by 3 matrices. So assume you have a matrix A which is 3 by 3, okay, with real entries. You are familiar with 3 by 3 matrices. That's the structure. It has 3 rows and 3 columns. So the inverse of this matrix, A inverse we have talked about before, is given using this formula. And what this formula says is 1 over the determinant of A times the adjugate of A. Determinant of 3 by 3 matrices, you are already familiar with them and you know how to find it from the previous videos. And for the adjugate of the 3 by 3 matrix is this big matrix. Now in this big matrix, what is new is these entries that are determinant of 2 by 2 matrices. Now what are these entries? If you look at this one, you take the first element of the matrix, you remove the column and the row, and whatever left you take the determinant of this part. And as for the second element here, you will take the second element of the matrix, you remove the row and the column, and you take the determinant of what is left. A21, A33, A31, A33, which are all here. Now for the third element, you continue like this, you remove the row and the column of the location of the corresponding element, and you take the determinant of the remaining numbers. And you continue in the same manner. If you look at this element here, you remove the column and the row. You see it is this location. So you remove the row and the column and you take the determinant of the remainder, which is A11, A31, A13, sorry, A21, A33. And the same story for all other elements. Now another thing here is these signs that are written in red. So you go like this, with the first element is plus, second minus, third plus, minus, plus, minus, plus, minus, plus. And after you are finished with this, you will take the transpose of this matrix. Now let's apply all this on a matrix A as given here. So you will need to take the determinant as the first thing. So the determinant of A is, I'm not going to compute this here. I assume you know how to find it already. The determinant is 1. Now to find the adjugate of A, what you will do, you will create a big matrix and it contains determinants. Okay, determinant of. Now this element 7, you remove the row and the column and you write determinant of the remaining numbers. 3, -1, 4, -2. And the same thing for the other numbers. For here, determinant of, you remove the row and the column of the number and you write the determinant of the remaining numbers. So 0, -1, -3, -2. Okay, and you continue like that. So for the third element, determinant of, you remove the row and the column of the number. So what is left is 0, 3, -3, and 4. Okay, and you continue in that manner. So I will not put the lines now. I will try to write all the other numbers myself. Determinant of 2, 1, 4, -2. Determinant of 7, 1, -3, -2, -3, -2. Determinant of 7, 2, -3, 4. Determinant of 2, 1, 3, -1. Determinant of 7, 1, 0, -1. And last, determinant of 7, 2, determinant of 0, 3. And now it's time to put the signs. So the first one is positive, negative, positive, negative, positive, negative, positive, negative, positive, and at the end you will take the transpose. So the answer for this, you will take determinants and get the final answer for each determinant. Don't forget the sign beforehand, before the determinant, and you should get negative 2, 3, 9, 8, negative 11, negative 34, negative 5, negative 5, 7, and 21. Okay, this matrix transpose. So after you transpose it, you should get the, so transpose, you will exchange the rows and the columns. So you take this row, you make it a column, negative 2, 3, 9, 8, negative 11, negative 34, negative 5, 7, 21. That's the adjugate. That is the adjugate of the given matrix A. So now we have computed the determinant, the adjugate. We are ready to write the inverse. So A inverse is 1 over determinant times adjugate of A, which is 1 over the determinant 1 times negative 2, 8, negative 5, 3, negative 11, 7, 9, negative 34, 21. That is the inverse of the given matrix A. Okay. Now, if in case you want to check it yourself, the same way we did it for 2 by 2 matrices, you can compute either A times A inverse or A inverse times A, and you should be getting identity matrix, which is 1 along the diagonal and otherwise 0. That's I3, identity matrix dimension 3, which confirms that your answer is correct. Okay, you can do it. Another example is this example. So we have two questions. It says, is this matrix invertible? Now, if you remember, we say that a matrix A is invertible if the determinant of A is not 0. Okay. Now, to answer this question, we need to take a determinant. And I assume you know how to take determinant. Once you solve it, you'll get minus 37, which is not equal to 0, which means that yes, A is invertible. Okay. Now, the other part of the question says, if it is invertible, find the inverse. So to find inverse, maybe you can remember A inverse is 1 over determinant of A. You should remember that, times the adjugate of A. Okay, that's the formula to find inverse. So we had the determinant already. We will try to work out the adjugate. So the adjugate of A is a big matrix, maybe even bigger than this, containing determinants. So for the first one, we remove the row and the column for 2, and we write the determinant of the remaining numbers, which is negative 2, 1, 2, 4, determinant of, remove this, and now it will be determinant of 3, 1, negative 1, 4, okay, we shouldn't get this transpose, determinant of, now you remove this row and column, remains 3, negative 2, negative 1, 2, determinant of, now we remove this number, the row and the column, what we have, 1, negative 1, 2, 4, and I continue writing the numbers from there. You can do it yourself. So it will be 2, negative 1, minus 1, 4, 2, 1, negative 1, 2, 1, negative 1, 2, 1, sorry, negative 2 here, it will come from there, and then determinant of 2, negative 1, 3, 1, determinant of 2, 1, 3, negative 2. Okay, it comes from that part, the first 2 by 2 matrix, block matrix. So now it's time to put the signs, so plus, minus, plus, minus, plus, minus, I should say positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, and you can find this matrix. It is going to be 10, negative 10, negative 13, 4, and here will be 4, plus 2, 6, negative 6, 7, negative 5, negative 1, negative 5, negative, last one is 7. Transpose. So you take the transpose, you will get negative 10, negative 13, 4, negative 6, 7, negative 5, negative 1, negative 5, negative 7. Okay, negative 1, negative 5. This is what? This is negative 4. Yes, I had written it correctly. 5, sorry, negative 4, 5, and 7. Yes, negative 6, 7, negative 5, negative 1, negative 5, and negative 7. So this number will be 2 times 1, 2, plus 3, 5, negative 5. Yes. Now, this is the adjugate. What we found is the adjugate. We have the determinant. We are ready to write down the inverse. So A inverse is 1 over the determinant of A times the adjugate of A, which is 1 over negative 37 times the adjugate, negative 10, negative 6, negative 1, negative 13, 7, negative 5, negative 4, negative 5, negative 7. Here you can leave it like this, or if you want you can take in the scalar to multiply by each entry and get a more simplified type of matrix. That will be the inverse, and if you leave it here it should be fine. This is the inverse. If you want to check whether you have done it correctly or not, the same way you can compute A inverse and see whether you get identity matrix or not. And that should confirm whether you have done it correctly or not. So this is all about finding the inverse of 3 by 3 matrices. I hope it was clear and easy. And I hope before you leave in the video, you are going to get a piece of paper and a pen and try to do the examples by yourself. This is the second example, and this is the first example. Okay, thank you very much for listening.